Okay, so there's definitely not a lot of writing in this particular situation. It's mostly a pay attention in this particular situation, which means you probably should not be on your cellular devices or your chromies. So, just paying attention. This won't take very long. And so we're going to talk about the different types of separation techniques that can occur when we're talking about separating a mixture. Now, when we go back to the different types of matter. There was pure substances, which we've kind of dealt with a little bit already, especially when we drew model of matter diagrams. And then there were mixtures. And the mixtures, when we talked about them, we basically said that they were like two or more different pure substances mixed together. And most mixtures, actually, I take that back, all mixtures can be separated by some type of physical means. That is, we use the physical properties of the parts of the mixture to separate them. So, going back to physical properties, you may recall that physical properties or physical changes, rather, are changes, which this is a review, that result in the same substance So that's a physical change. And examples of physical changes would be things like melting or dissolving or, I don't know, like ripping in half. So those are all examples of potential physical changes. And we are going to use the properties, the physical properties of substances to be able to separate them in the lab. And so we'll talk about different ways that we can do that. The first one is something called manual separation, also sometimes referred to as mechanical. And what that really means is that the object or substances that are going to be separated manually are often large enough that you could like grab with your fingers, or you could grab them with a tweezers or a forceps, or you could grab them with some other grabbing device like the claw. I don't know. But basically you're separating big solids from either liquid or other big solids. So over here on the left-hand side, I have a liquid with some red cubes in it. That liquid, I'm using tweezers or forceps to remove those cubes and putting them in a weigh boat. And when all is said and done, I have a pile of red cubes, and I have a beaker full of water in this case. So that's an example of manual separation. Another example of manual separation, if you have two larger solids that are two or more larger solids that are mixed together. Again, like those evil people who think it's funny to like put M&Ms and Skittles together. Like, I don't know why people do that, but some people do because I think it's funny.
That's gross.
Agreed. It's gross. So, but what you could do is you could like look in the bowl and look for the ones that have little M's on them and pick those out, and look for the ones that have little S's on them and pick those out. And then you can have a nice pile of M and M's and a nice pile of S's. And then you can eat those separately, I would imagine. So that's separation, mechanical separation. Another one is magnetism. So not all substances are magnetic, but some metals are. Not all metals are magnetic, but basically what you would do is you would take, actually, you ever wonder how like when you take your recyclables and you throw them in the recycling bin, like how the glass gets separated from the cans, gets separated from the paper, gets separated from the plastic? Like, you ever wonder that? Well, the answer to that question a lot of times is it has to do with the physical properties of the things they're trying to separate. So at one point or another, a recycling truck dumps its recycling load onto a conveyor belt, and the conveyor belt just starts traveling, and somebody's job is to stand there and look for things that don't belong there, like literal garbage or banana peels, or pieces of plastic that actually cannot be recycled. Then the next thing not the next thing, but a next step could potentially be running the conveyor belt under a large electromagnet, and they'll just pick up anything that is metallic. And then the next technique would be to simply Sometimes they will dump it into large vats of water, and they will use the property of density to separate things out that way. But that's kind of what we're getting at here with magnetism, is that in terms of magnetism, if there is a magnetic substance, you can literally use a magnet to separate it from the other substance. So in this example, I've got what appears to be a brown solid or liquid with silvery or grayish beads inside of it, and we're using the magnet there to grab those beads and put them into a weighboat, and now I have my brown liquidy solid and my beads separated, and we use the property of magnetism. Next one is filtration. Some of you might filtrate every day. I know I do at home. So in filtration, what you do is you generally have a liquid or a gas sometimes, and you have a lot of times two different states of matter in that solution. So in this case, in the case of my example here in the picture, I've got these green spheres and potentially water. And so we're going to pour the water and the green spheres through a porous membrane, and we're going to allow the water, in this case, to go through the membrane and the green spheres to stay behind. That membrane is a special name in chemistry class. It's called filter paper. At home, we're probably talking about coffee filters.
Isn't that a funnel?
Yes, it is a funnel with filter paper inside of it.
Oh.
Which that might be harder to see. And so there's two vocabulary terms that we used to make you know, but you don't need to know right now, but I'm going to talk about them anyway because I use them interchangeably. The stuff that's captured up here is called the residue. And the stuff that's collected in the bottom, the liquid, is called the filtrate. So the residue is often the solid. It's the part that is collected in the filter paper. And the filtrate is the liquid that is collected on the other side most often. So in labs, sometimes students will ask, after you filter something, do I keep this? And they're holding the flask with the liquid inside of it. And I'll be like, no. Or I'll be like, yes, because sometimes you might need to keep it, sometimes you might not to. So it's just kind of got to keep track of what you're supposed to be, what the target thing to keep is in this case. Technique number 4 is called decanting. Decanting is crazy, I think, because it's simple. Uses substances that have different densities and that are immiscible, which is a really, really fancy term for they don't mix well together or they don't mix together at all. The most common example of an immiscible substance or an immiscible situation that you might have in your life would be salad dressing that has like oil and or vinegar in it. The salad dressing, a lot of times if it's sitting in the refrigerator, will separate out. You'll have oil on top and vinegar on the bottom. And then you shake it up real good like that. And then you take that and then you pour it over the salad and you got the salady goodness of the dressing, right? But that's an example of two liquids that don't mix together well. So like salad dressing, specifically vinegar and oil. Okay. And so in theory, if you really wanted to separate those things in their salad dressing, you could take your salad dressing container that has the vinegar and the oil separated, and you could carefully pour off the oil, and you'd be left with the vinegar behind. In chemistry, though, we have a special tool for that. It's called a separatory funnel, which is right here. And it's basically a funnel with a valve at the bottom of it. And what you do is you fill the funnel with the two liquids that don't mix well together. You shake it up real good once, and then you let them separate. And once they're completely separated, you decant or you draw off the bottom part, which happens to be more dense. So this is more dense. And less dense. Okay. And so what you end up doing is you carefully remove the more dense material, and then until all that's left in the separatory funnel is the less dense material, and which in this particular example would be the oil. And then you can put the oil into another container, and then you have two separate and then you separated the mixture. Technique number 5 is probably my second favorite because I think it's fascinating. It's called distillation. So in the picture here, they talk about salt water, but but sometimes you can have like a beaker or a container that has 2 different liquids in it, and like one of them might be like, I don't know, water, which has a boiling point of, let's say, 100 degrees Celsius, and one of them might be like, I don't know, ethanol. And I'm pretty sure ethanol's boiling point is in the 60-ish range. So I'm going to put 65 degrees Celsius-ish. I'm probably wrong because I didn't look it up and I didn't prepare, but I think it's pretty close. But in any case, if you have those two liquids together, when you mix them up, you can't see the difference between the two of them generally. And as a result of that, if you heat the solution, the solution will heat up, it'll heat up until it gets to 65 degrees. At 65 degrees, it starts to boil rapidly. And when it's boiling rapidly, the ethanol in this case is the thing that's boiling, and the water is actually not. So the ethanol boils, it turns to a vapor, so it turns into gaseous ethanol, and then it travels up through this situation here, and eventually makes a right-hand turn into something called the condensing tube. And the condensing tube, so you remember how when you're a little kid and you take the straw and then you take the coffee straw, you know what I'm talking about, the really thin coffee straw, and you put the coffee straw inside of the straw and you're like, I'm drinking out of 2 straws, and you're like, I'm cool. And then your parents are like, you're so cool, but they said it in that voice that they're like, you're not that cool. And then you pay them back by just basically reminding them of how not cool they are right now. Right? No, you don't. Okay. Anyway, what I'm getting at is that the condensing tube is essentially a straw inside of a straw. The little tiny straw has the gas running through it, and the bigger straw has cold water running through it. And they never actually mix, but what the cold water does is it forces that gas to come back down to room temperature and condense and become a liquid. And so when you do this correctly, you end up with pure, whatever this is over here. If we're going to use ethanol, we'll say ethanol. And back over here, you would have water, right? And then if you really, really wanted to get the water out, you would just continue heating it until you got to 100 degrees Celsius, and then it would start boiling again. So it would boil at 65 and stay at 65 until all of the ethanol had vaporized, and then it would stop boiling until it got to 100 degrees, and then it would start boiling again. And that's what I think is fascinating about this. But it is what it is. Anyway, distillation. The last technique we need to talk about is crystallization. And in crystallization, it usually has to do when something has been dissolved. So like a solid has been dissolved. So in this case, it might be like your sugar or your water. Or how many of you have the water cup collection in your bedroom? You know what I'm talking about? You go grab a water cup and you drink most of it, but you leave it in your bedroom. And then the next day you grab another water cup and you drink most of it, but you leave it in your bedroom. And then your mom says, well, yeah, nowadays I guess it's a water bottle. But like back in the day, in a mythical time called the 90s, nobody carried around a water bottle. You just grab cups of water. And then you'd have 85 cups in your room, and somebody would come in your room and be like, where are all the cups? And you'd be like, I don't know. And then you'd take a pillow or a blanket and cover them because you didn't want to get in trouble. And then when nobody was looking, you'd put them in the sink. And a pro tip to put them in the sink and walk away. And then when somebody says where'd all these come from? You'd be like, oh. And so then what ends up happening, right? But have you ever noticed how if you leave water, specifically tap water, in a glass?
The bubbles, it's like bubbles.
Well, there are bubbles, but if you let all of the liquid evaporate out of it, all the water evaporate out of it, sometimes there's this white residue that's left behind. Have you ever seen that before? Yeah, that white residue is the stuff that's dissolved in the water. And it's not that it doesn't mean that the water is disgusting. What it means is that the water has stuff dissolved in it, like minerals or like iron or whatever else. So it's got some stuff dissolved in it, and as a result of that, that's what's left behind, and that's what essentially crystallation is. It's removing the water, and when it removes the water, you're left with some solid behind. And so that's crystallization. Sometimes we heat it to make it go faster. Sometimes we just let it evaporate. any questions about the 6 different types of separation techniques. Excellent. Okay. So you are going to end up using a couple, probably not all, but a couple of those techniques in your lab that we are going to start in about 5 minutes.